So we've gone from inter-switch connectivity, trunk ports, but we haven't been able to make the VLANs talk to each other yet, and that's what this section's for. We're going to have two things here. InterVlan routing enables routing between different VLANs. InterVlan connectivity requires a layer 3 device. We're going to look at two methods here. We're going to use a router on a stick, which will be the first one, and then we'll do switched virtual interfaces, which uses a layer 3 switch. VLANs are separate broadcast domains. This is the router on a stick, and let me bring this guy over here, my router on a stick. I have three VLANs here, VLAN 20, VLAN 30, and VLAN 40. And VLAN 20 up here, yeah, we've got some of them on one. There is a trunk port here. This one isn't configured yet. We have a gigabit port, gig 00 port, a gigabit port on the Cisco switch or Cisco router up here, and a gig port on the Cisco switch. We need to make this a trunk port so all of the VLANs can go on it. That's what trunks do. And then we're going to configure the router to be able to route between these trunk ports, or between these VLANs, trunk ports, VLANs. So we'll go to config T, and then it's interface gig 01, I think, switch port mode trunk. Do show it. Be sure I got that right one. Do show interface trunk, and so both of them are trunks now, and that's what I wanted to see. I've taken one of the trunk port, one of them off. Let's look here. VLAN 40 is not configured. That's the one we will configure when a minute is at the 50 seconds. The negotiation is going to go on here to see that these other two actually can go from one VLAN to the other VLAN, and that VLAN 40 can't. So let's see what we have. 30.3, I think, was this one over here. Yeah, 30.3. I think I tried this a little earlier, so it may already be here. 30.3 worked earlier. Let's see if it works now. 30.3. So we are going from one to the other. This one is IP config, CONFIG, is a 20.10, so it's on the 20 network. The other one's on the 30 network. We are now going from one to the other. If I try this guy here, since he's not configured yet, and you can see I tried him to be sure I undid the things that I wanted to undo to demonstrate this one. 30.3, timed out. It's going to time out, time out, time out. Instead of waiting for it to time out multiple times, we just get rid of that. Go over here into the router and do the configurations that we need to do. We're going to create what's called a sub-interface. And a sub-interface is a mechanism that allows us to put multiple IP addresses on a single physical interface, which works out pretty well for this. So instead of having to have all these different connections to the router, we can use a single interface, a gigabit interface for this thing. So we'll go to enable and config T. And in this phase, in the interface gig, interface, let's just do it and then we'll look at it. Gig 0/0, and this is going to be VLAN 40. I'm going to use a .40. One of the things that will help keep things sorted out, and especially when you start troubleshooting, is that you label everything consistently. VLAN 40, network, the network, the .40 network, interface 40. So we'll do that, change state to up. I could try here to put an IP address on it, and this is not going to work. IP address 192.168.40.1, 255.255.255.0, and it says that I can't do that. I have to configure it with an encapsulation protocol. IP routing on a LAN subinterface is only allowed if that subinterface is already configured as a part of an 802.10 or an 802.1 Q or ISL VLAN, and it is not. So what we have to do is to do the encapsulation, and the encapsulation here is .1Q, and then I'm doing the question mark so that you can see that you can walk through these things if you want to. And now we have to do the VLAN, because we have to tell it which VLAN this interface is associated with, and it's VLAN 40. And now I can do my IP address. I use the .1 addresses for these. So let's go back to this guy now. I kind of like to start from the one first. Let's see if we can ping 192.168.40.1, 40.1. If I can find the .1. And it works. And now let's see if we can ping the 30.1. Just the heck of it. Ping the default gateways, and we can. And that other one was what, 30.3, I think, maybe. Ping 30. Let's see if we can ping 30.3. So we can now get from one to the other using the router on a stick. Again, called a router on a stick because it's got a single interface. Looks like you're holding it up on a stick. The entire configuration of this thing is not really all that complex. You have to have a device. You've got to have a gigabit Ethernet or a fast Ethernet or something like that we can create a trunk port on. But if we do the show running configuration on it, we have the sub interfaces, interface gig 00.20 on the gig 00. The base interface, the gig 00, should not have an IP address. And we have to no IP address configured on it. And then we do the IP addresses and the .1Q, the encapsulation, and then the VLAN it's associated with. And again, the 20, and the 20 all together, to me, it makes it a little easier to keep things sorted out and to do the configuration, a little bit easier to do the configurations on them when we want to do that sort of thing. So ROAS, router on a stick. ROAS. That used to always mess me up because Roanoke, where I lived for a lot of years, Roanoke, Virginia, the airport code was ROA. Using multi-layer switches instead of the router on a stick, we can do that. Instead of configuring a router on a stick, if we got a layer 3 switch, a multi-layer switch, we can then do the configuration. Let me bring this thing back over here and see if I can find I'm not going to save that. My switched virtual interfaces is what it would be called, PQRS, and I've got two of them in here, and one of them looks too much like the other. SVI demo. Let's see what that looks like here. Yeah, this will work. Let's go down. This one looks too much like a router on a stick. I wasn't really wild about it. This one over here, while we're doing our spanning tree, let me be sure that it doesn't have the configurations that we don't want. Show IP interface. Brief. Can't spell brief. And I don't, so that is a good thing. We have VLAN 1. We have these downs and ups and so on and so forth. Before we start, we should have, between these two devices, we've got to have a trunk port, obviously. The other thing that you have to have, and would show up here, that we have to have on the device, is show VLAN. I'll do a show VLAN. We have to have the VLANs configured on it. The reason we have to have that is show, let's see, show spanning tree. I want to do that. Show IP, show interface trunk. I'll get to what I want to see here in a second. The reason we have to have that is the VLANs in the spanning tree, forwarding and not pruning, the VLANs allowed in the management domain. VLANs allowed on the trunk. If we don't have the VLANs, they're not going to go in the trunk. So they have to be configured in order to be able to use the trunk to get from one location to the other. But we do have the trunk port here, And then it says mode, switch port mode trunk on the other end. Obviously did the negotiation, encapsulation.1q. Native VLAN is the default. The status of this thing is trunking, which is what we want it to be. So, let's see, I was on this one, wasn't I? Yeah. So what we can do here is we have VLAN, 2 and 3, I think. Show VLAN. When we do that, VLAN 2 and VLAN 3. Config T. The first thing that we have to do on a layer 3 switch is enable routing. And that's just the IP routing command. If we don't do that, it's not going to route. So we do IP routing. The next thing we need to do is just configure our virtual interfaces. So let's say interface VLAN 2. Says we got it. Let's do an IP address of 192.168.2.1, and I think that those are the 2 and the 3 are the ones that I used. 255.255.255.0. And now let's do interface VLAN 3. And it'll be IP address of 192.168.3.1, 255.255.255.0. And then we can do a show IP interface brief. And we should have these guys. And let's see if we can ping. Well, I won't do us any good to ping there from there to there, will it? Let's see if we're working now. I mean, this should be all we really need to do. So let's go to this guy, to the 2.2 address here, and see if I've messed it up. See if we can ping 192.168.2.1. And sure enough, we can. And let's see if we can ping 3.1, and sure enough, we can. And let's see if we can ping, and I'm going to take a guess that the other one's 3.2, and see if this happens. The simulation takes a few seconds here for that to happen. Now we're going from one network to the other network using switched virtual interfaces on a layer 3 switch or a multi-layer switch. You'll hear them called both, either multi-layer switch or layer 3 switch. The other thing while we're on a multi-layer switch or a layer 3 switch that is kind of interesting is that I could go into one of these things, and let's go into config T and do interface fast Ethernet 0/15 and give it the no switch port command. I've now just modified this thing from a layer 2 port to a layer 3 port. So I could use it to get out of the device. And when we talk about routing, routers know about all of the networks that are directly connected to them. But the way the layer 3 switch, everything in here is a layer 2 port at birth. When the switch is unmodified, we can modify any or all of these ports to be forwarding using IP addresses instead of MAC addresses, and that's really what it does. It forwards using IP addresses in hardware rather than using MAC addresses. A little added there. Multi-layer switches. The switch virtual interface is a layer 3 logical interface. It acts like a physical interface, and we did that by just making an interface, and we called it VLAN whatever we wanted it to do and added an address to it. After we enabled routing on the layer 3 switch with the IP routing command, has to be done in order to do that. We don't have to have a separate physical router. If we've got layer 3 switches, we can do this. And a multi-layer switch, to perform it, we have to use the IP routing command in order for routing to take place. The switch virtual interfaces are created on layer 2 and layer 3 switches. And we had one, when we did the setup command on the layer 2 switch, we had an interface VLAN 1, which was there by default. We can put an IP address on it in order to communicate with it to do remote administration. So we can create switch virtual interfaces on both layer 2 and layer 3 switches. We can only route on layer 3 switches. The routing engine must have a routing engine at layer 3 switch. Layer 2 switches are capable of switch virtual interfaces but can't route between them. We have the port types here. Layer 2 interface is associated with a physical port, a switch port. Switch virtual interface used for management. Switch virtual interface, and we can create other ones on the layer 2 switch if we want to do that. The layer 3 is associated with a VLAN. The VLAN 1 switch virtual interface, and then on the layer 3 we have support for layer 2 and layer 3 protocols on it. That's why when I connected it earlier with those, I had to tell it what the encapsulation was with the layer 3 switch. Routed, in order to make it a routed port, we use the no switch port command, which we just did. Once we do the no switch port command, we can then put an IP address on it. Switch virtual interface, what we just did here, VLAN 10, VLAN 20, a little bit different ones, but we did the VLAN, create the layer 2 VLAN. We do have to have the VLANs on these devices, otherwise they can't go through the trunks in order to make them work. The step-by-step, and I think this basically is what we did. We enabled routing. I didn't check the running config to verify that IP routing is enabled, but it obviously was because it worked. The VLANs to be routed, add or delete the VLANs as necessary to the layer 3 switch. They all have to be there or they're not going to be allowed to get into the trunk to send the information back and forth. Determine the network addresses for the VLANs, create the switch virtual interfaces, interface VLAN, whatever, the IP address, subnet mask. No shut, we didn't really have to do that. You can do that, and it's always a safe thing to do the no shutdown command on interfaces. But the switch told me, or the message, the configuration message that I got, the information message said that it was up, that the interface was up for that. Figure a default route on the switch. And we haven't done default routes, we will, but IP route 0.0.0, and the default route's like the default gateway. IP address of the gateway, and then to verify with the show IP route. Well, we will do routing for those. Switched virtual interfaces for these things. The routers use interfaces or sub-interfaces to interconnect multiple VLANs. And if you think about it on the router, eventually we're going to run out of interfaces. We have a limited number of them. That's why the sub-interfaces and the switched virtual interfaces work well for us, because we can just keep making them. And the router on the stick works well with the sub-interfaces because we can just keep making them. Eventually, if you get too much traffic, we're obviously going to overload these things. Switch virtual interfaces, depictions here, interface VLAN 1, the same thing that we just did on these things. We could do an IP default gateway if we wanted to, the 1.1 to do those. I had already made my devices, had them configured as the .1 addresses for the default gateways. That's why it worked. Methods for the InterVlanRouting, the router on a stick, which we configured, a router where the configuration allows a single physical interface to route traffic between multiple VLANs by using sub-interfaces with the interface gig 00/0 dot whatever we want it to be. And again, recommend that when you do these things, you be consistent with the VLAN numbers, the network addresses, and all of the things that we did in the sub-interfaces, so that you can look at it and see, okay, this one 20, 20, 20, it makes sense. This one's 20, 30, 30. Well, I made a mistake somewhere with this thing because they don't match up. We do have to have a trunk port that goes to the router, so we have to have either a gigabit port or fast Ethernet port or something like that connect to the switch. We configure the trunking on the switch itself. The router won't take a switch port mode trunk command. The sub interfaces InterVlan is performed by the router accepting the VLAN tagged information to do these things, and then uses the same physical interface, multiple sub-interfaces to do that. The router has an IP address on each sub-interface, the things that we did. These are the labs. There are a couple troubleshooting switching issues, a couple more slides here. VLAN issues, inter-switch connectivity issues, incorrect IP addressing, missing VLANs are the things that we could have on these things. The demo that I did earlier this morning was set up with a number of these errors. Both ports are in dynamic auto. That wasn't one of them. The trunk will not be formed. But that happens every time we connect two of the devices together. We either got to go configure one of them as a switch port dynamic desirable, or give a switch port mode trunk command, which will automatically do that. Will occur only when the access port VLAN on one switch is in the same native VLAN or the same VLAN for the 802.1q in the other switch for these things. If the VLAN numbers don't match, the frames can be forwarded. If the native VLAN does not match the VLAN on the access port, the frames will be part of a different VLAN and no longer forwarded correctly, and that becomes an issue. The VTP domain, VLAN trunking domain name mismatch, if you get that, it says you got a mismatch and it's not going to share information, and it basically shuts everything down. Native VLAN mismatch, we configured, put the port in an inconsistent mode, said that we have an issue, gave us a lot of error messages. The inter-switch connectivity, inter-switching, as well as the switching issues, we got to have a trunk port to do these things. Either that, we have a whole lot of connectivity. The native VLANs have to match. The VTP domains have to match. You're not getting them. Be sure that the switch isn't in a transparent mode, that it's not getting the VLAN information from the server. Can't create it. Well, probably going to be in client mode. It's not getting it. Could be in transparent mode. It's not sending it. Transparent mode. The things that need to match on these things that we have from one to the other.